This is the Anycubic Predator. It's a huge and massive Delta bot with a 370 millimeter diameter build area. It has an LCD touchscreen, auto level, a filament detector, and a Tri-Gorilla Pro 32-bit board with integrated stepper drivers. It came in a box so big that the UPS guy had to give me a hand to bring it to the house. The package weighed 56 pounds, and it's not a bare bones system. It came with a full kilogram of white PLA+, about 5 other colors of shorter length PLA, a metal spatula for digging parts off a plate, a bunch of hex keys, an owner's manual that was printed in color. They really wanted to give you the full package that you could use and maintain this over a period of time. It took me 55 minutes to get it from the point of unboxing it to having it ready to run. It wasn't hard at all. You just have to bolt together the main pillars to the top and bottom and then plug in a few wiring harnesses. It's not like a kit, for example. It's really just more of assembly. And it's definitely easier than assembling a bed from IKEA, for example. So I would say it's really only an extra 40 minutes on top of if you just got a fully assembled printer and were simply unboxing it. So why get a DeltaBot printer? Well, there's 2 main kinds of motion systems. There's a Cartesian, which is the simple XY system, and then Delta, which has the 3 arms that do a coordinated movement. And it's much more complex, but that makes it a lot more interesting to watch. It kind of reminds me of the probe droid from the beginning of The Empire Strikes Back. I mean, it's a real robot. It's just very cool, different. I like having things that are different. And it also has one great advantage in that there's very little moving mass. The hot end and the small cooling fans on it are all that moves. In fact, even the stepper motor itself is not on the part that moves. And you may know about these Bowden tube print heads. They have the advantage of lower mass in the moving part, and the downside is that if you're using a flexible filament, it pushes on it from far away, and it's a bit like pushing on a noodle in that it can bend in the Teflon tube. But they had a clever solution to that. They don't have like a full-length Bowden tube. They just have a very short one. So the stepper motor is actually hanging right above the hot end. And it's high enough up so that the motion system doesn't have to move the motor back and forth, but it's close enough so that it virtually acts like a direct drive. So the absolute opposite of that, a system which has the most moving mass, are the printers where the whole table, the whole build plate moves back and forth on the y-axis. And I have a Maker Gear M2 that works that way. And most of the low-cost popular printers work that way. So it's a well-proven way of doing something, but you can't really run them as fast because not only is the build tray itself fairly heavy, but imagine using a whole roll of filament that weighs 1 kilogram and having that try to move back and forth quickly. It leads to ringing around corners of objects if you go at a high speed. So if you want to print really fast, a Delta system is great for that. And I mean, normally to get that kind of low mass system in a Cartesian, you have to go to something like an Ultimaker or a Hypercube Core XY system. Those are all very expensive printers. You know, here we are with a DeltaBot that is in the below $600 price range, and it has the advantages of the low moving mass of some of those systems. So I find that exciting, just like I would find an Ultimaker or a Zortrax exciting, except those are hugely expensive, not to mention quite small. So here we have something with an interesting motion system, a massive build size, and it's under $600. So what's the downside to a Delta? Well, the traditional downside is that they can be hard to calibrate because you have these 3 arms and they interact with each other in a complex fashion. So if they're not exactly the same length, maybe it's not going to see the build plate as level, even if it is level. And it used to be hard to get all of that set up and figured out. But this has an auto level probe, and it goes around and touches the plate, and it deals with all that internally. So that kind of sidestepped what the traditional issue is with Deltas as far as setup goes. I haven't seen any downside to this. In fact, I printed this threaded part, and there's no distortion on it. Not only does this nut turn on this bolt, but when I'm feeling it, it feels actually quite smooth. I don't get a sense that any of these parts are ovalized in any way, which is something that could happen if it wasn't calibrated perfectly. So I've been having a great success with it, and I'm going to show you some different parts that I've printed and talk about them some more. On the left is a part that I designed and printed on the Predator using the white PLA Plus material that came with the printer. On the right is the same part file printed on my Anycubic Photon resin printer. They look about the same. This build plate has a very powerful heater. It goes right up to 100 degrees Celsius in just a few minutes. And I wanted to see how hot I could get it, so I set it for 120, even though I knew it couldn't reach that. And it got up to 113 without any enclosure when my room was 21 degrees Celsius, which is about 70 degrees Fahrenheit. And after I put an enclosure on the printer, it got up to 116. So I actually just set it for 100 for ABS, but if you wanted to do 110, that would definitely work. And I use Simplify 3D, and you know, some other people will use Cura. They have to be set up in different ways. But with Simplify, you tell it that it's a Delta bot. You don't put in the 370. You have to tell it the largest rectangle that could be inscribed into the 370 millimeter. In this case, it's 260 by 260 millimeters. And only if you put that in will Simplify show a cylinder with a 370 millimeter diameter. The height of this is listed as 455 millimeters. I actually have mine set for 460, just because I tested it and I went from the top, and I think I got 452. So I just set it at 450 to be conservative. And then as far as the 370, I wasn't able to get every millimeter of that 370. I did test 365 and that worked. And I didn't bother to test between 365 and 370 because it's close enough, it doesn't really matter. I know that you can get the full 370, but what you have to do is get your pulleys, and as the arms extend outward, you have to make sure they don't contact with any of the three pulleys, and if they do, then you just have to lower them a few millimeters. I haven't bothered to do that. I've been able to print quite big things. In fact, I'm going to show you this 360 millimeter tray that I made. This tray is used to cure my resin SLA printed parts. I had to make 600 of these parts, and they have to be cured under ultraviolet light when they're made with UV sensitive resin. Now, my curing oven wasn't big enough to actually deal with all this, so I wanted to do it outdoors. And I tried just taking all of my parts and putting them on cardboard outside, but it was kind of a mess because the wind blew them over, and it was hard to rotate them so that the sun got different parts of it. So what I did was design this tray that holds 60 of them, and it has a hole in the center, and I could put it on a phonograph. I finally found a use for a phonograph, and it will rotate in the sun. This is something I could not have made on a smaller printer, and something about that size. When you start making big prints, it takes a long time to print them. So it came with 5 nozzles. It came with a 0.4, 0.5, 0.6, 0.7, and 0.8. And I'm kind of torn because I love the detail I get from the 0.4, but I love the speed I get from the 0.8. And yes, in theory you can change them, but I'm just not a fan of adjusting things. I like setting them up and not touching them. So ultimately I did move to the 0.8, and I'm using my maker gear with a 0.4 for smaller things. And I found that I can print really big things quickly, like this torso, for example. This thing's huge. I mean, it's practically life size. And I don't know how long it took to print, but not very long. So if you're going to get a big printer, I think you should think about why you have a big printer, and it should be to print big things. And if you're going to print big things, why not use the 0.8 millimeter nozzle? So there's a few ways to send a part to the printer. One is to write the G code onto the SD card and then put that in the printer, and it will run all by itself. Another is to have it run from Cura or Simplify or some other slicer from a Mac or a PC. But what I've been doing is using Octoprint. This is something that you could get as an image that you download onto an SD card, and you put it into a Raspberry Pi. And then the Raspberry Pi acts as a print server, and it drives the printer. And what's nice about it is that the Pi has Wi-Fi. So I could send this part from my computer. I could just be sitting in bed with my laptop, and the part goes to the Raspberry Pi. Once it starts printing, I'm not connected to anything. It just runs from the Pi, and it basically gives the printer Wi-Fi without it having that feature naturally. And I could monitor the printing from my iPhone remotely, and there's a webcam on it. You could buy a webcam for $15 or $20, and if there was a print failure and I see like a pile of spaghetti filament forming, I could just hit cancel from wherever I am. So I don't feel like I have to be home or I have to have someone home when it's printing. I can monitor it and stop it if there were to be a problem. This motion system can be tuned to perfection. So when I first got mine, this whole system could fall under its own weight. What you can do is use the included wrench and tighten the eccentrics that are on the side of each one of these trolleys. And the goal is to make them tight enough so that this won't fall, but not so tight that it binds. And what I notice is that if you make it a little too tight, sometimes you can find like a minor flat spot in the wheel, and this will go jump, 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 jump. So what I did was identify which wheel that was and make it just loose enough so that this is perfectly smooth. And then you check the side to side to make sure there's no wobble. You repeat that for all of them, and you could really perfect it for nice smooth motion. I did some mods to the printer, which is something that I just always do, so I'm not saying that it needs mods, but I always look for stuff I can do for projects. And the first thing I did was added an hour meter to it, and I wanted this because I just like to keep track of things. It's kind of like having an odometer on your car. So like I know, for example, I've already used this printer for over 120 hours. And all you do is you buy an electrical hour meter. They're on eBay, Amazon, AliExpress. They cost between $8 and $16, depending on if you want it really quickly from Amazon or if you want to wait a few weeks from China. And I had to find a place to attach it. So there is one fan on the hot end that turns on when the hot end goes above 60 degrees Celsius, and it turns off when it's powered down and cools down. So I connected it to that, and it's easy to see where that wire runs to the main circuit board. You just tap into that, and you can look in the notes on this video. I put a link to my Thingiverse file if you want to print an enclosure to the hour meter that I like. But I really like having an hour meter, and I always like doing it before I use the printer for the first time. So my last few printers have gotten these right from the start. The second mod I did was to make a new spool holder. I actually have a bunch of ABS I bought more than 6 years ago when I got some earlier printers. And those printers just couldn't print ABS. Even my Maker Gear M2, I even built an IKEA enclosure for it. it always had layer splitting and warp. And for some reason, this Predator does a really good job with ABS. And it may be because the build plate, the heated build plate is just so large that it fully encompasses the part with warmth. But I've had no trouble with ABS with this. The only problem is my ABS was made so long ago that the spools weren't really standardized. They have smaller holes, they're wider, and they wouldn't fit on the spool holder. So I designed this spool holder, and it works great. It fits my octave spools, for example. The part file for this is in my Thingiverse account, which I'm also linking into the video description. The next mod I did was to put in some Triangle Lab smoothers. They're known as TL smoothers, and there's different kinds. There's 4 diode and 8 diode. I watched some videos where people tried different ones, and the 4 diode ones didn't work, and the 8 diode ones sometimes worked. I also saw someone try them on a Predator, and they definitely had an improvement. What you're looking for is a surface texture known as salmon skin, and it's something that is usually particular to Delta bot printers. I see a little of it on some of my prints. For example, the side of these bike pedals printed in ABS. I can see this triangle diamond shape forming, and I think that is part of the salmon skin artifact. It actually doesn't bother me at all, but I thought, why not? These TL smoothers are $13, $14. Might as well try them. So this is my pedal without the TL smoother, and this is my pedal with it. And they're slightly different, but they're about the same. So in my single test that I did, I can't see a difference. I don't regret buying them because someone else saw a difference in the part that they printed. So, you know, it probably works some of the time, but you really don't need it. On the other hand, there is a mod that definitely works, is very inexpensive, and you have to do this one. So I saw someone else put rubber bands around the ends of the arms, and I knew why they were doing it. It was to tighten up the motion and remove any slop that was in the mechanism. So I asked them how it worked, and they said it worked great, and they showed me a video of someone else doing it. So I thought I would try it, but I didn't want to use rubber bands, so I got this selection of O-rings, and I found that the number 39 in silicone was a good O-ring for it. You wrap it around twice, and you put it over the beginning and end of each set of arms. So you need 6 of these in total. I got them from McMaster-Carr, but you can get a 25-pack on Amazon for under $6, and that's a much better deal. So whether you buy number 39 or 40 O-rings, or you just use rubber bands, either way, this definitely tightened up the rigidity of the system. So, you know, here I am tugging on the system before the mod, and you can see there's a bit of motion going on. It's unwanted and could use some improvement. But with the O-rings in place, it's dramatically better. It's probably 90% better, or a better way to say it would be 90% of the excess motion is eliminated. It's much better. In fact, when I'm wiggling this right now, I feel like it's just moving the entire printer and not just the head. The other mod I did was build an enclosure. Now, I've built enclosures before. For my maker gear, I had to get an IKEA cabinet, which was quite expensive and not quite big enough. I built it around my printer, and it did keep it warmer to help ABS part dimensional stability, but it made accessing the printer quite difficult. And this is way better because this printer's huge. So it also has this structure built in where you can just add side panels to it. And it has these channels on the sides of the aluminum, or aluminium if you're from the UK, that you can stick the panels into and keep them in place. What I did was went to Michael's Arts and Crafts, and I bought 20 by 30 inch sheets. They have white foam core, or you could get black corrugated plastic. One reason why I got the black plastic, aside from the fact that black looks really cool, is that it has some flex to it. That allowed me to make these slightly oversized so that you have to bow them out in order to stay locked in place. And that was nice because it kept the panels away from the round heated build platform at the bottom, which can get hot enough to possibly, I don't know if it would cause issues with the plastic, but I didn't want it to touch it directly. So I found that if you cut these to 18.75 inches wide, it creates that nice bowed out effect. And then I got a 20 by 30 inch acrylic clear poster frame, which are fairly low cost. And I'm using that from the front. And I'm hanging that from clips that I designed and printed on my Maker Gear. And you can actually get those, you can get the file for that on my Thingiverse account. Look for the link in the video description, and it works really well. I found that it allowed the build plate to get up to 116 degrees Celsius. When you do put your enclosure on, it's actually important to leave some space down here because this hot end, when it goes to the 370 millimeter edge, can push beyond this side panel if it were not bowed out and if it didn't have a gap at the bottom. So the 20 by 30 inch panels are actually perfect because they have the right amount of gap. So I did about 5 modifications, and some people have even gone further. There's someone who changed the main controller board to a duet board, which is known as, you know, the board that people want these days. It's nice because it has Wi-Fi, and it also has stepper drivers that give really quiet performance to the stepper motors. Personally, I have not found this printer to be too loud. It's actually in my bedroom, and when I run it, I run a Honeywell HEPA filter, which has a really loud fan. So the noise of the printer just doesn't bother me at all. I know what you're thinking. The Tri-Gorilla board only has 16 microsteps, and there are boards which can do 256. The problem is, as you increase the number of microsteps, the incremental torque per microstep drops off in a big way. Resolution increases, but accuracy actually gets worse. For example, 116 microsteps have 16 times the max holding torque of 256 steps. So more microsteps are not always better. The existing 116 stepping is 12.5 micron resolution on the belts. That works out to about 14 microns on the XY, depending on where you are on the build plate, in the center or the edge, which is already about an order of magnitude better than even a thinner Z-layer height. In other words, 116 stepping is probably the best setting to use anyway. Too many exciting printers you can get in this price range. There's the TiVo Little Monster, that's about $800, which is more than $200 extra. It's actually smaller in size. It's about the same. They're both all metal printers. If you want to go to a CME CNC, those are more like $1,500 to $2,500. And historically, they're made out of wood, which is not as nice as this aluminum and steel. And then anything else exciting that doesn't have a moving Y platform and has a low mass moving head is going to be something like an Ultimaker or a Zortrax or a Core XY. And assembled, those are all going to be a lot of money. But would I spend $900 on something with a moving Y gantry? No. Once you're in that price range, you can get something like this that doesn't have that kind of basic motion system that's really limited and keeps it from doing high-speed motion.